Hello, today I'm going to talk about magnetic levitation train. It is interesting to imagine train that moves without wheels. They float above the lines without contacting the rail. These kinds of trains are called maglev trains. The concept of this train started in the 20th century in 1934. However, it wasn't manifested until 1960s. So, now let's know how it works. To understand the functionality of maglev train, the system is divided into levitation, propulsion, and guidance. Levitation is the quality which makes the train system remain suspending above the guideway, and it is divided into two types: electrodynamic suspension and electromagnetic suspension. The electromagnetic suspension depends on the magnetic force that levitates the train above the rail. In other words, the electromagnets on the rail repels with the magnets under the train. Then we'll talk about propulsion. Propulsion is the force responsible for the forward moving of the train. To gain propulsion, the train and the superconducting magnets generate some current in coils on the opposite sides of the guideway. This will make the north and south poles of the magnet change in series. The last part is guidance. Guidance is responsible for sustaining the train at the center of the guideway. There are three kinds of rails: standard rails, transrapid guideway, and MLX guideway. In the case of transrapid rail, there is an electromagnetic rail on both sides of the guideway. They ensure that the train stays in its track. For the MLX case, the levitation rails on each side of the rail are linked to one another. As the train moves to one of the sides, there is a resistance force that keeps the train at the center, and this case uses both guiding and levitation. Here we come to the end of the presentation, and thank you for listening.